Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore a remarkable new clue hidden at the edge of our solar system, where distant icy worlds preserve the gravitational scars of the Sun's long-lost siblings and reveal how quickly our star escaped its crowded birth cluster billions of years ago. What follows is the clearest insight yet into when the Sun drifted apart. Our Sun wasn't born as a lone star and, in fact, had several more companions. This theory has been talked about time and again, but what we don't know is how long it stayed with its siblings before drifting away. A new study has tried to answer this question, along with how many other stars were born alongside our Sun billions of years ago. Scientists believe that the Sun collapsed out of a cloud of precursor gas and dust, and it was not alone, and in fact, was part of a litter. Despite being packed closely, they all moved on separate paths. However, they were destined to move away from each other. But in doing so, they made things tough for each other. Whenever two stars moved close to each other, their intense gravity severely disrupted their protoplanetary systems. The objects orbiting at the farthest points suffered the most, with some of them even being thrown out of the system. These events possibly left marks on the edges of the solar system. A team led by Amir Siraj of Princeton University tried to decode these scars to answer two questions: the number of stars born near the Sun and the amount of time the Sun spent in its birth cluster. For this, they specifically looked at the distant sednoids, the 9 objects that live at the most distant point from the Sun. The sednoids typically orbit beyond 400 AU, but all of them stay on planes that are fairly aligned with the planets. This relatively tight distribution of inclinations led Siraj and his team to conclude that our Sun did not face too much of a rough time as it went about separating from the other stars. The team simulated many different close flybys and their influence on the distant sednoids, while capping the Sun's stay to be less than or equal to 5 billion years per cubic parsec. Assuming there were only 100 stars per cubic parsec, the scientists concluded that the Sun left the most dangerous part of the cluster within 50 million years. This conclusion led them to state that the sednoids reached their extreme orbits almost immediately after. If this were the case, then the latest finding on how long it took the Sun to leave its siblings becomes quite credible. However, it is not clear why they ended up at such extreme reaches of the solar system. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.